For numbers 13 and 14, you're finding the volume of composite solids, and both of these will be addition problems because you have one solid in addition to another. You're not removing one from another. So you're going to find the volume of each solid and then add the ones that you find together. So in number 13, you have a cylinder and then a cone on the top. So we're going to be adding the volume of a cylinder to a cone. So since a cone is like a pyramid, remember it's 1/3 the base area times the height. The base is a circle, so that's pi r squared, and then there's the perpendicular height of that cone. The volume of a cylinder is like that of a prism. It's base area times height, and the base is a circle, so pi r squared h. So the cone has a 1/3, the cylinder does not. We're given this unit right here all the way across the circle is 12 inches. So that would be the circle's diameter, which means the radius would be 6 inches. And that's the radius for both the cylinder and the cone. So we know both of those. We're given 38 inches for the height of the cylinder. Even though that's a horizontal measurement, it's the distance between the two circular bases. So that's its height. When we look at the height of the cone, it's not the 10 inches. The 10 inches, if you'll remember, is what we call the slant height. That's a number we'll use when we get into surface area, but that's not used for volume. For volume, we need the height of the cone. So I've drawn in a perpendicular height and then drawn in a radius, knowing that those would make a right angle together. So I've created a right triangle. This is my radius halfway across the circle, which is 6. I'm given the hypotenuse, which is the 10 inches. I need to come up with the vertical or perpendicular height. If you can recognize this as the Pythagorean triple, the 3, 4, 5, that's all just been doubled, we get the 6, 8, 10. So here's the leg that's the 6, here's the hypotenuse that's the 10, the other leg has to be 8. If you don't recognize that, then you need to do the Pythagorean theorem. Your 6 squared plus your b squared equals your 10 squared. So you have 36 and 100. You're going to subtract the 36 from both sides to get b squared equals 64. 100 minus 36 is 64. Take the square root of 64, which is 8. So either way, you're going to get that height to be 8. So once you know the radius and height for both the cone and the cylinder, you're ready to find the volume of each and add them together. So the volume of the cone will be 1/3 pi r squared h. So 1/3 pi times 6 squared times 8. You're going to add the volume of the cylinder, which is just pi r squared h. So pi 6 squared times 38. So 6 squared is 36. 36 is 12. 12 times 8 is 96. So we get 96 pi for the volume of the cone. And then on the cylinder, 6 squared is 36. 36 times 38 is 1,368 pi for the cylinder. Since both of these have a pi, they are like terms and can be added together. So you can add their coefficients of 96 and 1,368 to get a total of 1,464 pi. Don't forget the pi. And since this is volume, it's cubic units, so inches cubed. That's the total volume of the cylinder and cone together.